And this week we will introduce the last type of the supervised machine learning model, which is neural networks. Uh, we now we nowadays have heard this model a lot from news, from social media. So neural network has not become very success, especially for handling the natural language processing and also or analyze the videos or images. So neural network is a very complicated model. So we are going to touch the surface of the neural network. So we will just introduce probably the simplest type of the neural network. And we will also talk about the model selection so that now we have introduced the most common supervised machine learning models. So how can you select the models for your project? See if you have a data set and you train the data with different types of models, and which one will be the best for you. Okay, so the neural network. So the neural network model, or sometimes we call it artificial neural network. So that is a model that for both regression and classification. Okay, so neural network model can be used for regression and also for classification. It is called a neural network because it has been motivated by the way that by the way that our brain operates. So our brain will receive those signals. Those neurons will receive signals and they will pass the signals to the other neurons, and also by doing that we kind of can process information. Okay, so neural network is using the same structure. So we have those different units. So those are simulate the neurons, and they will pass information to each to the other neurons or to the other unit in the network model. Um, and also they are connected. So it's so the so it is called neural network because it is motivated by the way that human brain operates. However, so it is still not as powerful as human brains. Okay, as far as I know, that our human brains is still far way complicated than the neurons because we still do not fully understand how our human brains are actually working, and also it is more powerful than the computers that we have. So most neural networks are black box. So this may sound like a little bit surprising, but because it is very complicated, so we built the model, so we know the structure, but we don't know that how the information has been. How the decision or how the type kind of like code learning has been formed by the machine. So we can always see the result like the parameters, the weight. However, so inspecting those weights actually will not give you much more information about how they resolve the problem. So so in another way that so understanding or interpret the details of those parameters or those outputs, especially those middle output, will not help you to understand how the model is functioning. However, so the result of the model is super great. So it has been successfully applied in many fields. Okay, so the model that we are going to talk today is called multi-layer perceptrons. So that's MLP. Uh, MLP is one type of this feed-forward neural network. Okay, so it's one type of this feed-forward network, and feed-forward network is also one type of the artificial neural network. So we're going to touch we'll just talk about one, probably the most the simplest model, neural network, and there are a lot of neural network models available, and probably you will need to spend an entire semester to learn the other models. So MLP can be viewed as a generalization of the linear models. Okay, so the simplest way is that, so we can think about, like, say we have the input layer and also we have an output layer. Okay, and for example, in this case, input layer, we have four inputs. Okay, 1, 2, 3, 4. So and also we have one output. Okay, so one output. So you can think those input as the independent variables in the linear regression models. Okay, and also output, for example, if we are going to predict the house price based on the number of the bathrooms and also number of the bedrooms. Okay, and also the area. Okay, and also probably the lot size. Okay, so for example, we are going to predict the price by using those four features or the four columns. So here, each single feature will be an input, and the final output will be the house price. Okay, and we also have those weights. So those weights are the parameters or the coefficient for each independent variable. So for example, the first weight multiplies the number of the bathrooms plus the second weight multiplies the number of bedrooms, and so on. And also finally, we'll also add a bias. Okay, we'll also add bias so that we'll use that one to predict the house price. Okay, so that is equivalent to the linear regression model. So however, in the MLP, we will add more hidden layers. Okay, more hidden layers, or the hidden units that represent the intermediate processing step. Okay, so for example here, so instead of using two layers, the input layer and also output layer, we provide a hidden layer. And in this hidden layer, we said, okay, we want 3 neurons or 3 unit. Okay, so in that case, we will compute the value of the hidden units first. Okay, and next we are using the value of the hidden units to calculate the final output, the final price. So for example, the first hidden layer that will be calculated by all the 4 inputs times its corresponding weights. Okay, so this is the weight between the first input and also first hidden unit, and this is the first input, and plus the weight for the second unit, and between the first hidden unit. Okay, the second input feature and also first hidden layer, plus, and now we use this weight. So this weight is the third input, between the third input and also first hidden layer. Okay, and also continue. Okay, and also plus bias. And the second unit is the value of the second unit is calculated in this way, the same way, and also value of the third unit is calculated in this way. And finally, when we calculate the final output, for example the price, so we're using the value of this first hidden unit times the weight between the hidden unit and also output unit, plus the value of the second hidden unit times the weight between the output and also hidden unit, and plus the third one times its weight between the output, and plus a bias. Okay, so we always added we always add bytes for each single layer, except for the output. Okay, so that is a multi-layer structure, and you can bring more layers, and you can, for each single layer, you can add more units, so that will make the model to be more complicated.